Welcome to our lesson on adding and subtracting using standard form. For the do now task in part A, I would like you to convert the numbers from normal numbers into numbers in standard form. Part B, reverse the numbers, so take them from standard form and convert them into normal numbers. And part C, add the following numbers but pay very careful attention to the place value of each number, as that's going to become important later in the lesson. If you are then happy with those questions, you can have a go at the extension question, which simply says, can you think of any examples of numbers that look like they are in standard form but are actually not? Why is this the case? So I'd now like you to pause the recording and have a go at the questions. Welcome back. In section A, we need to take the numbers and write them in standard form. So the first number is just 1 times 10 to the 5, 2 times 10 to the 4. Number 3 is slightly trickier. Remember from your lessons before, we only have one number in front of the decimal point, so it's 4.6 times 10 to the 4, 2.08 times 10 to the 6, and in number 5, because we're dealing with a decimal, our power of 10 is negative, so it's 3.2 times 10 to the negative 2. Part B, converting back the other way. Just be careful when you count the number of zeros in question 5. And in part C, hopefully nobody tripped themselves up with this. It's fairly straightforward. The only one that really causes any issue is actually number 4, because the 4 and the 5 in the tens column both need to be added together. And it's this ability to line up the numbers that we're going to be using later in the lesson. For those of you who have come up with various things for the extension solutions, then obviously you can have a look on YouTube, Google, and find some things that may support what you've come up with. So let's have a quick look then. When we do calculations with space, planets and galaxies, the numbers are so big that we need to use standard form to make calculations manageable. By the end of this lesson, we will try to work out if the mass of all the planets is as great as the mass of the Sun. So our success criteria, we need to be able to perform addition and subtraction using standard form numbers. We need to be able to understand why we use standard form numbers and how to perform calculations with them. And lastly, we need to be able to perform more complex addition and subtractions using multiple numbers in standard form. So I'd like you to take a few seconds to have a look at the question below, and then we will have a look at its solution. If you need more time, just hit pause. So initially what we're going to do then is we're going to take this number here and we're going to write it as just a normal number. If we then take this number here, 2 times 10 to the 3, we can also write that as a normal number. So we get 1,000 plus 2,000 is 3,000, which we could then choose to write back in standard form as 3 times 10 to the power 3. So now let's have a look at this question. It's slightly more complicated because here we have 10 to the power 4 and here we have 10 to the power 3. So when we convert our two numbers, what we're going to do initially is deal with the 2.2 times 10 to the 4 and the 1.5 times 10 to the 3, which gives us 22,000 plus 1,500, which gives us the sum 23,500, which can then be put back into standard form as 2.35 times 10 to the 4. What I would now like you to do is take a look at the do this question. Obviously, it's fairly similar to the one we've just done, except there's a subtraction. If you need more time, please just pause the video. Welcome back. So again, what are we going to do? We're going to take our two numbers. We're going to convert them into normal numbers. So 56,000 subtract 4,200 gives us 51,800, which we can then write in standard form. You can always come back to this slide if you need to revisit the examples. So now what I'm going to ask you to do is tackle the following 6 questions. So please press pause on the video and have a go at the questions below. Welcome back. So looking down the first column, the answers are 8 times 10 to the 2, 3.12 times 10 to the 4, and 3.45 times 10 to the 5. And down the second column, 3.3 times 10 to the 3, 1.48 times 10 to the 3, and 5.72 times 10 to the 1. Now, if you take a look at part A and B, you will see that in actual fact, the 3 and the 5 simply added to make 8, and the 7.8 subtract the 4.5 gave us 3.3. So because we had the same powers of 10, our place value was in a similar arrangement. We could actually just deal with the numbers themselves quite easily. So we're going to try and use that approach in a moment. So, is this correct? If I have two numbers in standard form, I can change one of the numbers such that the indices are the same. Now remember that the indices here, this is a 4 and this one is a 3. So what we want to do is take this 6 times 10 to the 3. And if we divide the 6 by 10, we get 0.6. So we need to multiply by 10 on the power. So we've gone from 10 to the power 3 to 10 to the power 4. Then we can simply add the 8 and the 0.6. So yes, it is. So there is a shortcut to this. So you can do it by converting the numbers, or you can do it by making sure that the indices have the same value. So if you look on the left-hand side, therefore, there's another example. We can take our two numbers, write them so they have the same powers of 10, combine the 0.24 and the 3.2 now, and to get our solution. So what I would like you to do is pause the video, choose whichever method you prefer, and have a go at the next 3 questions. Welcome back, and the solutions are 1.8 times 10 to the 11, because the 8 and the 9, whilst the powers of 10 are the same, by adding the 8 and the 9, we move to a number greater than 10, so we've ended up increasing the powers of 10. Question 2 and question 3. In question 3, you need to just be careful with the number of zeros between the 8 and the 4. So now what I would like you to do is take a look at the 3 statements that are in the rectangles and see if you can fill in the missing values, and then have a look at the 3 questions towards the bottom of the page where we have some numbers in standard form and some numbers not in standard form. So if you'd like to pause the video and have a look at those, please. Welcome back. So in the top one, we've got the 6 and we've got a 2 and a 3, and we want to make 6.23. So the 6 must be in a larger place value column than the 2, so it's 10 to the power 4. In the next one, we have the 6 and the 2, 3, but this time we need to make 2 and 9. So I'm thinking 23 and 6 makes 29, in which case we need to add those two numbers, and we need to arrange so that our 2.3 has a larger value, a larger power of 10 than the 6 does to sort out the place value, so we need the 5. The last one, we have the 6 and the 2.3 to make 8.3, so that means the 2 and the 6 are in the same position with regard to the powers of 10, so they're both -6. And the non-standard questions in the bottom, you can convert either into standard form with the same power of 10, or probably more easily, convert the standard form numbers and the powers of 10 into normal numbers. So now back to our hook question. True or false? The sun weighs more than all of the planets put together. So we have the mass of the sun is 2 times 10 to the 30, and then we have the mass of all the individual planets below. So what I would now like you to do is try and add up and find the total mass for all of the planets in the solar system and compare it with the mass of the Sun. So if you'd like to pause the video. And welcome back. So what we're going to do then is we're going to add up the masses of the planets, and I'm just going to start at the top. So quick running total then. Mercury plus Venus, 5.3 times 10 to the 24. Add in the Earth, and we're now up to 1.1 times 10 to the power 25. Add in the mass of Mars. Now we're going to add in Jupiter, which is the most massive planet, so we're going to add in 2 times 10 to the 27. And we actually now end up with 2.0119 times 10 to the 27. Then we can add in the mass of Saturn and Uranus, and finally the mass of Neptune. So we now have a mass of all the planets to be 2.8019 times 10 to the power 27. What we need to now do is compare that to the mass of the Sun. So if we look at the Sun, it's 2 times 10 to the 30. So whilst 2.8 does look to be larger than 2, it's the powers of 10 that define the place value system that we need to be interested in. So there's the mass of all our planets, and it turns out that 2 times 10 to the 30 is greater, of course, than 2.8 times 10 to the 27, because we've moved 30 positions along a place value diagram as opposed to 27. So in answer to the question, it is true, the Sun is more massive than all of the planets in the solar system combined. Now, similarly, we use standard form as a way of performing calculations with numbers that are either too big or too small. And one that often springs to mind is when people talk about the storage capacity of phones, computers, and so on. So if we had a phone with storage of 8 gigabytes, that's 8 times 10 to the 9 bytes. If we stored some games on it, and they have a combined size of 5.6 times 10 to the 9 bytes, we now want to work out if there is enough storage to add an Arctic Monkeys album, 7.4 times 10 to the 8 bytes, a Fortnite mobile app, 1.8 times 10 to the 9 bytes, and a music video, which is 9.6 times 10 to the 7 bytes. So what I would like you to do is pause the video and see if you can work out the solution to this question. Welcome back. So, if we start initially with the storage on the phone and we subtract off the amount of storage we have already used for the 2 games, we are left with the value of 2.4 times 10 to the 9. So the next thing we can do is to work out the amount of storage that would be required for the Arctic Monkeys albums, etc., etc. So what are we going to do? We have our 1.8 times 10 to the 9 for the Fortnite mobile, and we've got 5.4 times 10 to the 8. If we then include the rest of the information, you can see that hopefully the value 2.43 times 10 to the 6 is greater than the 2.34 times 10 to the 9 that we had left on the phone. So back to our success criteria. We know how to perform simple addition and subtraction. Hopefully we can now use standard form numbers and perform calculations with them. And hopefully again we're beginning to perform more complex additions and subtractions, be that using a change to the standard form or dealing with lots of numbers with different powers on them.